A very good morning and welcome you all to the webinar today. My name is Anshu Pandey. I'm going to be the speaker for the webinar today. Right, so let's go ahead and get started. So this webinar is on the topic on understanding how do we deploy an AI or ML project on cloud platforms. Although it is more focusing on cloud, though we'll have a very detailed walkthrough with a generic idea on AI and machine learning topics and some sort of best practices. Moving forward, we'll get to see how do we develop a model to deploy a model on cloud. Preferably in this case, we're going to be using up AWS cloud. And as a part of that, we will be simply creating an EC2 virtual machine, a VM on EC2 engine, and putting up the Flask code over there, right? So that's how we'll get to see that out, right? So let's go ahead, get started. I would encourage you all to ask questions, as many as possible throughout the session. That would be helpful in keeping the session and this webinar more interactive. And the more questions we ask, the more detailed we can go ahead with the topic. So feel free to ask more questions. And yeah, that's it, right? Let's get started. So what I do is I work as an AI and data consultant for Putty Ventures and Tech Ventures as well. As part of my role, in last 4-5 years, I have been able to help organizations in architecting the AI and data projects, mentoring, monitoring the data and AI projects, and also I get involved in coding and developing AI and data projects as part of accelerating the existing and or ongoing projects with them. I got good chance to work with majority of the banking financial clients across Southeast Asia, South Asia, and Middle East. Got also good chance to interact with majority of the Asian firms working in the space of telecom and defense as well. That's all about my experience. Besides that, from last around few years, I'm also involved into training as well. As a part of it, I help corporate companies in building their AI and data teams. Right, that's about it. Let's go ahead and get started. Well, this is going to be a bit the discussion that we're going to have next for, I would say, around 30 minutes. Is going to be a bit high-level discussion. From a bird's eye point of view, we're going to have a quick overview idea. As this webinar is not to teach AI and data science, rather it is to get a managerial or leadership point of view. What should be the right approach and the best practices and the flow that goes in, right? So in the next 30 minutes, it's going to be theoretical, a lot of concepts, a lot of approach, best practices, the standard methods, frameworks is what we're going to discuss, right? So let's go ahead and get started. So when it comes to any AI and data project, right, specifically data projects, right? So when we say AI and data, primarily data science consumes AI, right? But a lot of people assume or they interpret NLP and computer vision as AI. And when you apply machine learning and AI algorithms and structured data, they call it data science. Well, that section is correct. Well, when you apply machine learning and AI on structured data, it's data science. Whereas when you apply it on unstructured images and videos without audio, that's computer vision. And when you apply it on NLP, text or audio, that's NLP. So these are the three main frameworks, right? But majority of the projects which are ongoing, majority of the developments, applications developed are in the field of data science. For that reason, data science has gained more popularity. And data science projects are usually, you can say, periodic projects, right? So they need periodic updation, maintenance, and retraining of the ML models as well. Whereas majority of the computer vision and NLP projects are like one-time job. So in the moving forward, the flow that we're going to pick up is going to be a data science project out of AI and ML. Out of NLP and computer, the whole AI landscape, right? except the AI and ML. But again, the framework remains the same for ML at least. It just sections of feature engineering differs a bit of it. Right. So for any standard ML project or specific data science project, this is a generic framework. The same thing. This slide represents what it was on the previous slide. So this is a very generic framework. We can call it more like a 10-step to do framework for any AI and data project. Right. So the step one starts primarily with the understanding to domain exploration. One of the challenge in any of the AI and data project that enterprises, or I would say a lot of data scientists face, is that they lack knowledge of business domain. They lack intersecting statistics with the business outcomes and compliances involved in that specific business domain. And that's where in at least in last 5 years, there has been good chunk of data science projects which were developed but not deployed in the industry. Right. Numerous banks in India as well as outside have experimented hundreds of such ML models which they can use. The data science team has been able to develop them, but then majority of those, I would say, or a larger chunk of those ML models developed, tested well, has been rejected by the business teams, auditors, governing bodies such as RBI, government organizations, the business rules, and the banks itself. Reason being, relevant to any business, there is always a requirement, or you can say there is always a regulatory limitation. There is always a accountability limitation. For example, if I give you a very simple use case of, let's say, face recognition. If I develop a face recognition model, at the end of the day, my client would only want to know how much is accuracy of this model, how accurate can it predict the faces, or can it identify or recognize faces. The client wouldn't want to know how is it identifying faces, how is it identifying your nose, whether it is considering nose, ears, eyes, and lips. They may not want to get into bits and pieces of how the recognition is happening. In majority of the computer vision projects and NLP, accountability is not super important. Accountability is never a compulsory ask from the business. But at the same time, if you look at a data project, like let's say for a banking company, if I have to develop a model to predict whether the customer should be given the loan or not, the model can be developed very accurately. Let's say in production, if the model predicts for any customer that this customer shouldn't be given the loan, even if the prediction is accurate, though the bank, the customer, the auditors, the stakeholders within the bank would also want to know why should not we give the loan to this customer. They would want to know that how this prediction or decision of yes versus no is made for a specific customer. So in banking or in numerous other business scenarios, accountability, explainability is super important in addition to making prediction, right? Otherwise, people do not trust AI or they don't trust ML, right? So majority of the deep learning or advanced algorithms are not accountable, are not explainable, are mostly gray box or black box models. And that's one of the primary reason, that they are not deployed, right? So it's important that, when you start with the first project, a very important aspect is to do domain exploration, understand the business domain. What are the restrictions of that business domain? What are the asks of that business domain, right? What are the common challenges in that business domain, whether you're doing it for banking or telecom or defense, right? Or you're doing it for education or healthcare, right? Healthcare may have different limitations, different asks compared to what a banking client may have. So it's important to understand the business process, identifying how the data is being generated, whether there is a biasness in the data or not, understand the proper data collection process which is in place, understand the standard beliefs in the business which are unverified or which are just assumptions, right? This is not a technical or coding step, right? This is around more on discussion, getting to interact with the business stakeholders, business managers, the people who work on the ground, getting their point of view in terms of understanding how do they look at their customer, how is the customer maturity, the target market where this machine learning model has to be deployed, right? So this is one of the super important step where majority of the data scientists or AI engineers overlook, and this should be in the right framework, this should be the very first step to go ahead with, even before starting with the coding, right? And this particular step and the kind of interpretations and decisions that you take at this step may differ from project to project, right? So one of the key skill set that is required in the today's market, in addition to understanding of algorithm, is what are the limitations of those algorithms, the strength of those algorithms, and blending that with the strength and limitations of every business case, right? So let's say once I know linear regression, logistic regression, or decision tree, neural network algorithm, that knowledge is going to remain same and always applicable any business case that I work with. But whether that algorithm is applicable in a certain scenario or not, that interpretation, that decision may keep on changing problem to problem and domain to domain as well, right? So that makes the first step a super important step, and the accuracy, or you can say the usefulness of all other steps heavily depends on this step specifically, right? Moving forward, the next step goes in as data collection. Data collection is again another super important thing, right? Where let's say as a part of my ML project, if I fail to collect right data, my ML model would be of no use. So collecting data from all possible dimensions, inside the business, outside the business, different units, different stakeholders, getting to know how the data is generated, how accurate data can be, or how accurate it has been in past while using that data for different other applications. Performing a generic exploration to understand structure of data, modeling it to make it useful and interpretable. Further step goes in as data cleaning, where definitely when you collect data from the business or real data or raw data, it's going to be having a lot of challenges. You may have to deal with missing value, duplicate entries, unnatural data, outliers, right? Exceptional cases, duplicities, right? Maybe biased data, incorrect reporting. After dealing with all these, again, these deals, or you can say these handlings should be on both the ways, the business interpretation way plus the statistical approach. The further step that goes in is more around feature engineering, where we do the data modeling and select the right data to be fed to the machine learning algorithm. There have been very standard approach or methods in statistics for structured data and data visualization approach to be able to identify which attributes are more relevant and are making sense in context to the target variable. So a few of the methods listed here could be ANOVA, chi-square test, mutual information, correlation analysis. Furthermore, the fifth step goes in pre-processing, where we model the data again in a format the machine learning algorithm should learn from, maybe converting categories into numbers, converting categories from capital case to small case, right? Building encoders or pipelines to transform data so as to be fed to the ML algorithm. And finally, it goes into selection of algorithms. We'll talk later a little bit more detail about the selection of algorithms in practice. And then it goes around, assessing the performance of ML model, how good the ML model is. So based on the type of model, classification, regression, you would want to pick which model is better and which you'd want to pick which attribute or scoring technique to use to judge the performance of model. Again, the performance need not to be assessed only with context to the efficiency in terms of accuracy or good predictions. It also needs to be assessed in terms of latency, how fast the model is at making prediction, the amount of parameter tuning required, or pre-processing required for the model, and a lot of other terms, right? How good and how robust it can be in production, how much affected it can be from outliers or unnatural values. At the same time, then it goes in optimization tuning. In case your performance is not good, then we update or improve that by some standard approach or methods. And then we finally deploy it in production over using REST API. And this is what our focus is going to be for the day, right? And finally, in some cases, you may have to monitor the performance in production if required. So this is the whole 10-step framework, I would say, which goes in for any standard data science project. I hope this makes sense. Let me know if you have any question at this stage. Good to move forward. All right, great. Let's take a step ahead here. Right. So whenever we do development, we're going to write code, right? Few suggestions for writing code are that the experimentation code at the first stage or first level is going to be more research in nature, and it should focus more on understandability, explainability, minimal abstraction, and as much as visualization and statistical interpretations. Furthermore, so whenever we do development, the first phase of writing code goes in that manner. Second phase of writing code would be again more oriented to or transforming the previous code into more around object-oriented programming approach, adding more security parameters, adding exception or error handling parameters to it. So the first round of code should not include those complexities because that makes it a little difficult to debug the code or debug the approach. Right. So the experimentation code primarily should focus on understandability, ease of readability, small pieces, less of abstraction as less as possible, lot of visualization, counts, interpretations, explanation, notes, right? And then again, we always do second round we sort of transform the same code in the form of with the OOPS approach, with a lot of abstractions, right, with error handling, exception handling scenarios as well. Right. Now, whenever we start with any structured data use case, we always have to or should go ahead with performing detailed EDA. Detailed EDA helps us to get fair idea of what data is, what use cases, what problems are, what how attributes are impacting the target variable. Detailed EDA may include performing univariate analysis where we try to judge and analyze each variable individually. It may include bivariate analysis where we analyze each independent variable in context to the dependent variable. How is it impacting, or how is that relation shifting over time or shifting over change in the values of the variables. Multivariate analytics is where we analyze the effect of multiple independent variables on dependent variable together if they are making some sense. Based on these interpretations and analysis, it also helps us to get very good intuition around which set of algorithms may be a good choice. For example, if multivariate analysis shows that a lot of variables have nonlinear pattern or nonlinear impact on a target variable, then you may not want to go for linear models. You may want to pick, you may not want to pick, let's say, linear logistic or naive Bayes. You may want to pick distant tree or neural networks for that reason. Also, performing dimensional reduction, performing factor analysis on the top of it can help us to get even more clear idea in terms of how variables are shifting together, moving together, and are representing a little similar information. And finally, clustering of similar observations can help to get even more idea on what are these specific segments present and maybe which variables will make sense when included with certain other variables. Besides this, when it comes to feature selection, the step number 4, there are standard methods to do that. Data visualization definitely is one out of them. Then analyzing correlation, variability of the individual features, performing hypothesis testing approach such as ANOVA, chi-square, mutual information, and using built-in ML methods such as regularization and forward backward chaining, right, are the specific approach to perform better feature selection. Right. That was one thing about it. Again, these methods may keep on changing based on the type of variable we're analyzing. For categorical to categorical, let's say suggested approach are to go for bar plot, chi-square, mutual information, numeric to numeric, scatter plot, ANOVA, categorical numeric, ANOVA, probability distribution analysis, and mutual information. This was around a little bit of data preparation, data engineering, and pre-processing. Now let's shift to the main idea, machine learning. As you know, machine learning is primarily about a set of algorithms from bucket of AI, which can learn from data. And there are 3 typical types of learning algorithms: supervised machine learning, unsupervised machine learning, and reinforcement learning. Supervised machine learning is where we solve the problems which are regression, classification, of making predictions in general. And it always needs labeled business data. Supervised machine learning algorithms learn from labeled data two important things at this stage. First, they do not remember or store or memorize the training data, right? So even if my training data is of 100 GB, a trained supervised model would be of certainly, let's say, certain 100 KB or 2 KB or 1 KB maybe. Second is, once we train the supervised learning model and the trained model is deployed to production, in production, they do not perform any sort of real-time learning. A lot of people do have misconception that algorithm will itself evolve over a period of time by learning automatically. Well, that doesn't happen with supervised machine learning algorithms. Supervised machine learning models stay static in production unless we manually retrain them. And usually we retrain them manually after validating data. We don't let them get trained and improve automatically. On the other hand, unsupervised machine learning algorithms are not used to make predictions. Rather, they are used to uncover or discover unknown hidden behavior or pattern, which can be helpful in forming some relations, taking some decisions in the business. Right. These algorithms need unlabeled data, and we let them keep on getting trained in production automatically. So they more of, you can say, learn in near real time. Quite a similar way, reinforcement learning algorithms, right, also get to learn in production, but they mostly perform feedback-based learning. They learn from feedback. Right, that's one idea. There's a question why upsampling and downsampling techniques are required. Well, reason it is, so upsampling and downsampling techniques are primarily to handle data imbalance, right? So let me go back to the previous step. We were talking about the data science framework here. So let's say we are doing data collection and we are trying to build a model to predict whether the customer should be given credit card or not. And let us say that the bank has captured data from the year 2000 to 2010. Okay, so they have captured data from 2000 to 2010. Now it is very logical that in those 10 years, the customers who would have applied for credit card were mostly male customers. So if they take data from that tenure, it is likely that the data is going to be having gender bias, right? Majority of the customer would have applied for loan is male, and very less of customers would have applied for loan would be female. Now, when we train a machine learning algorithm with that data, it is likely that the machine learning algorithm is going to learn that bias, and it may learn a pattern that male customers should be given the credit card and female customers should not be. Well, that gender bias may not be present in the year of 2021, or possibly based on ethical and compliance and regulatory body limitations, we may not afford to have that gender bias. So whenever we get such biased data or imbalanced data, to make it balanced, we do undersampling or oversampling, or you can say undersampling or oversampling, right? So that's one idea. Now again, undersampling, oversampling of data is different compared to upsampling or downsampling of images, right? So upsampling, downsampling is also something, a context which is covered in images in context of convolutional neural networks. So that is a different approach or different story one way. So here, when we have imbalanced class data, that's where we prefer doing oversampling or undersampling, which is more around, let's say, we can decrease, undersampling could be, we can decrease the number of male customer data and bring it equal to female, or we can copy the female customer data and bring it equal to male. So that's one context that goes in here when it comes to under or oversampling. Now, when it comes to upsampling, downsampling, these keywords are more precisely relevant to convolutional neural network. That's a deep learning algorithm. And there, the approach of upsampling or downsampling is to reduce, downsampling is to reduce the size of image, whereas upsampling is to increase the size of image. Upsampling would be required whenever you're doing image formation, right? For example, GANs would be a scenario where you're trying to build a fake image, would be where you would want to use upsampling, or else it could be another scenario of segmentation, right? The image segmentation, semantic or instance segmentation, there we do upsampling where we're trying to form an image. Downsampling where you do classification, or let's say you're trying to extract features out of images. Downsampling simply leads to reduce the size of images by losing irrelevant or slightly less relevant data, right? So only to keep relevant data in the images. So that's another context, right? So I hope that answers your question, sir. The idea on oversampling, undersampling is one story, which is more around relevant to the volume of data. and like handling imbalance class issue, and upsampling, downsampling is again another approach which is more specifically relevant to convolutional neural networks. Are we good? Right. So let's take a step ahead here. Right. So this is where we're talking about the idea to understanding supervised, unsupervised, and reinforcement. So within supervised, we get primarily two types of problem: regression and classification. Any problem where you're trying to make prediction and you're trying to predict a numeric attribute, that's a regression problem. Example could be predicting housing prices or predicting the fare of a ride. Classification, when your target variable is a categorical variable, example could be predicting customer churn or predicting type of email. We have a lot of similar, aligned to regression, one more scenario called time series forecasting. Well, the reason it is separately specified here because the algorithms that we use for time series data differ than that of cross-sectional data, right? So for time series data, you usually go for regression problem, and we there more of use different set of algorithms such as ARIMA and SARIMA and exponential smoothing techniques. But primarily, majority of the time series problems, almost all of the time series problems are regression problems. In the unsupervised machine learning, there are multiple types of problems. Few of them are mentioned here, such as clustering, where we talk about categorization of observations based on similarity in the properties, like customer segmentation or stock segmentation. Anomaly detection is more around detecting suspicious observations, like fraud detection. Damage reduction is about merging features or extracting relevant information from large number of features. Recommendation system is around recommending items relevant to the user's history or the current items being viewed. So that's whole about the a typical machine learning landscape here. I hope this ML landscape makes sense here so far, everyone. Right. Right. Let's take a step ahead from here. So supervised machine learning, as we know, there are multiple algorithms under supervised, right? Primarily, the structure of supervised could be that you start with labeled data, right? We load that data in the programming environment, and we perform all sorts of cleaning on data, do the feature selection, train the algorithm, and then assess the train model using test data set. There are multiple algorithms under supervised bucket, right? Some of them are linear models and some of them are non-linear models, right? So examples of linear model could be linear regression, linear SVM. Non-linear models could be decision tree and sorted machines, right? Now, when do we use linear versus non-linear models? Linear models are comparatively faster. Non-linear models are slow in latency. At the same time, linear models are less likely to overfit. Non-linear models are more likely to overfit. So how do you decide that? When you perform EDA, if you find that majority of your features have good correlation with the target attribute, that means there's good amount of linear relationship with the target attribute, a good idea is to go for linear models. If in case majority of the features do not show good linear relationship with the target attribute, a good idea is to go for non-linear models. Right. That's one idea. And quite a similar way, it also goes into classification. Classification, we have multiple linear models, examples such as linear SVM or logistic regression, neo-Bayes, non-linear models such as decision tree, neural networks, KNN as well. Similar in time series forecasting, we have trend-based models and no trend-based models. Trend-based models are the one where the data is, even if the data is not stationary, it's doable, it's useful, whereas no trend-based models require always stationary data. Right. Furthermore, if you talk about linear regression, it's simply y hat equal mx plus c, where m is a coefficient and c is a constant. We can have multiple linear regression where they have multiple features, and polynomial regression where we have polynomial versions of the feature. The standard approach is you feed the label data to the equation, get the cost function, use gradient descent to optimize the cost function by updating the parameters M and C. That's one iteration of learning process, which keeps on going ahead unless the value of cost function goes less than a threshold. The standard equation is y hat equal mx plus c. The cost function could be specified for regression problem as j equals 1 by n summation of y minus y hat square. And the objective is to minimize j, which is cost function. And that's where we go for gradient descent algorithm, which helps us to do that as new parameter equals old parameters minus learning rate into del j by del w. LR here is learning rate, which is deciding how fast the algorithm can learn from data. The value of LR always ranges between 0 to 1. Linear regression is widely used in real estate, medicines, for demand forecasting, marketing as well. Right. To assess the performance of regression model, we usually use one of the standard approach as R-square score. There's also a modified version of R-square score, that is adjusted R-square score. Logistic regression, on the other hand, is another linear model used for solving classification problems. To assess the performance of classification, we use metrics such as accuracy, recall, precision, F1 score, AUC on ROC curve, and confusion matrix. The idea of logistic regression is that it's modification of linear regression with the help of sigmoid activation function or logistic function, which always transforms the output of linear regression, one way to say, into a value between 0 to 1, which we want to modify further, or we use it to threshold it and classify into class 1 or 0. It's a simple linear model, much faster and very widely used in data science problems in industry. Majority of the successfully deployed models in industry are today running on logistic regression actually. Decision tree, on the other hand, the third most preferred model for data science problems, right? And it's a non-linear model. Supervised can be also used for multi-class classification, used for regression as well. There are two approaches for classification, the Gini index approach and entropy. Both are a way to represent cost function. In majority of the cases, both are similar, but in some cases, on a large volume of data, Gini index can be faster than entropy approach. For regression, decision tree uses variance reduction approach, where it tries to reduce the variance or variability of the target attribute. Decision tree is an explainable model. That's one of the key advantage of it. Besides that, it's a non-linear model and faster, at the same time more powerful. It can also learn the relationship between the features itself in terms of how is it impacting the target attribute. Right. That's one idea. There's a few of the hyperparameters that we need to tune with decision tree. Random forest, on the other hand, is an ensemble technique coming from the bucket of bagging. So in ensemble, we have bagging, boosting, and stacking approach. So a bagging technique where it builds randomly selected multiple trees, right, from the randomly selected data. Very widely used for ensemble techniques, are widely used for data science problems. Then shifts to deep learning, right? Neural networks, very widely popular, used for computer vision and NLP scenarios, right? Neural networks are the most complex algorithms today, and majority of the advancements in deep learning are happening on the top of neural networks. Inspired from human brain architecture, primarily a neuron does two steps, weighted sum and computation activation function. Neural networks are more complex, but at times they can be slower, at times they can be bulky and heavy, and they are much faster, the pro of it, right? And they are very accurate as well. They need a lot of tuning and optimization at the same time. There have been multiple architectures for neural networks, and in deep learning, we have numerous architectures which are used for solving different set of problems. LSTMs, RNNs, and GRUs widely used for solving time series problems to numerous sequence-based problems in NLP as well. Autoencoders, on the other hand, used for denoising images, unsupervised machine learning, anomaly detection, dimensionality reduction as well. Convolutional networks used widely for image processing and computer vision applications, Boltzmann machines for recommendation engines, Overfield network Markov chain models for feedback-based networks and pattern recognition. GANs for image formation, right? In quite a similar way, we have multiple other architectures of neural networks being developed and researched today. Neural networks have few more popular, but then numerous other hyperparameters tuned with, but few popular include the type of activation function, the optimizer to be used, the learning rate, right? The cost function definition as well, and the size of hidden layers and the number of neurons in the hidden layers. That was about whole or mostly idea of supervised machine learning. Shifting to unsupervised, one of the very popular problems that we get to solve is clustering. A very popular algorithm in clustering is K-means clustering. Primarily does 3 steps: taking random centroids, center allocation, and or you can say cluster allocation and center calculation. Widely used for segmentation of customers, segmentation of data, segmentation of stocks as well. Now there's a little cheat sheet, or you can say a standard framework in terms of how do you choose the right algorithm for a specific use case. Each algorithm has its own set of strengths and limitations, right? Some of the algorithms are, good at doing certain jobs. Let's see how do we deal with that. We'll come back to this slide later. So some of the algorithms have, can be used for solving both regression classification. Some of the algorithms are only limited to classification or regression. Some of the algorithms are interpretable, whereas some of them are not. Some of the algorithms are easy to explain to others, some of them are not. Some of the algorithms are pretty good at accuracy. You can achieve highest level of accuracy with them. With some, that may not be possible to get great accuracy. Some of the algorithms are much faster to train. Some of them are slower, right? The prediction speed is much faster versus moderate, right? The amount of hyperparameter tuning would be faster versus slower, or less versus more. Similarly, some algorithms are good at working on small data or volume of data. Some of the algorithms necessarily need large volume of data. Some of the algorithms are good at handling a lot of unrelevant features, or they cannot handle, and some of the algorithms can handle that. They learn automatically the feature interaction, whereas some of them cannot, right? Some of them give us probability, whereas some of them not. Some of them are linear versus some of them are not. Some of them require feature scaling necessarily, some of them don't. So each algorithm has its own set of needs, applicability, right? The limitations and strength. Based on the type of use case you're dealing with, the kind of scenario you're dealing with, you may want to pick the relevant one. Once you pick the relevant one, again, you may get into a situation where you may have to do optimization. So you may get into a situation where a model is underfitting or overfitting. When it is underfitting, good suggestions could be that you may want to get more features. No need to get more rows, right? Try additional polynomial features. If you're putting regularization or penalty, decrease the penalty coefficient, increase the complexity of algorithms, or try more nonlinear algorithm. If in case you got into the situation of overfitting, get more rows, no need to get more columns. In fact, drop the irrelevant or slightly less relevant columns. Try increasing the penalty or decreasing the complexity of algorithm as well. Are few of the best practices in general. Again, from algorithm specific, there would be more suggestions or best practices that will come up. For example, neural network, or computer vision, doing data augmentation could be a way to handle overfitting. Dropout optimization, right, versus batch normalization, right, are standard approach also for handling overfitting. Similarly, in decision tree, decreasing certain parameters versus increasing certain parameters could be a way out to increase or handle overfitting. That was one idea about it, right? That was one idea about it, right, so far. So this was so far idea around the understanding on how do we deal in different situations, and a little bit of summarized idea on machine learning techniques as well. So until here so far, are we good till here? Any questions before we take a step ahead? Because now we're going to get to work on a use case and try out developing a model and deploying it in production. Yeah, so this PPT can be shared, right? You can just message in the chat your email ID to Tech Trunk, right? So there's a co-host Tech Trunk. To them, you can drop a message and they should be sort of able to share that. Right, are we good? Sure. All right, so let's take a step ahead, and now we're going to go ahead and looking at an example on implementing ML solution over here, right? Here we go. So I'm going to launch Jupyter Notebook, right? And we're going to see which data set we're going to get to work with. Right. What is exactly the data imbalance issue, right? The data imbalance in the sense, let us say, sir, the example that we talked about, right? Let's say that example, or maybe in another example we can talk about. Let us say that we have to solve the problem of credit card fraud detection using supervised machine learning. So in credit card fraud detection, if we take the data from the bank or from the certain financial body, so in a day, if you take data of 1 day, so it may happen that in 1 day there would be 50,000 transactions that has happened. Now, how many of those transactions are going to be fraud versus non-fraud? So you can say, as a part of label data, it may happen that out of 50,000, hardly 1,000 transactions would be fraud, and mostly 49,000 transactions would be non-fraud transaction. So now if we have to do classification, we have to predict whether a new transaction will be fraud or not fraud. For that, if we consume this data, but in this data, around 95% of the observations are from class 0, known fraud. Only 5 or less than 5% of the observations are from class 1, which is yes, fraud. This is data imbalance. So your data is not equally distributed in two classes, right? When the data is not equally or uniformly distributed across two classes, that's data imbalance. So if you're doing a classification problem, sir, and if in case your target variable is skewed, that's a generic idea of data imbalance. If it is having uniform distribution, that's a data balance, you can say. So whether you're doing a regression or classification problem, if you have a skewed target variable, that's data imbalance. The challenge, the problem with this is, if you develop the model, if the machine learning model blindly says that all the transactions are not fraud, in that case also the machine learning model will be 95% accurate. The accuracy of the model will be 95%, right? If it blindly says all the transactions are not fraud, right? So machine learning models do not give much better performance in such scenario. They get biased towards the bigger category, right, which is non-fraud transaction. They get biased towards that, and they usually predict that all the transactions are not fraud. And it becomes very difficult to bring it to the balance situation where it rightly identifies fraud transactions as fraud and non-fraud as non-fraud. I hope I'm able to communicate the understanding of the issue of data imbalance. So in context to the target category, it would be difficult to achieve balanced accuracy or pretty good, let's say, true positives or recall in that case. In case if there is a data imbalance with context to a feature, an attribute, that leads to the data biasness and biasness in the model as well. For example, the example that we discussed about loan application. Let us say if I take the data of, credit card application, if I take the data of customers who were given credit card versus customer who were rejected with a credit card from 2000 to 2010 for any bank, let's say State Bank of India. So what will happen in 2000 to 2010, majority of the customers who would have applied for credit card would be male customers. So at this stage, if I take data from 2000 to 2010, if I have data of, let's say, 5,000 applicants, in the data of 5,000 applicants, most of the applicants would be male customers. So most of the accepted credit card accepted customers would be male customers. So if one of the column of the data is gender, the algorithm is likely to learn that male customers should be given credit card versus female customers should not be. So because of that imbalance present in the data, it generates a biasness in the data. And because of that biasness in the data, the algorithm gets biased towards gender, right? So that's a gender biased algorithm you get in, or a model you get at the end of the day. So imbalanced data or imbalanced class in features leads to biasness, which is not ethical or correct. Imbalanced class present in target variable will lead to bad model, or a model being biased towards a specific class and not making right predictions. An inaccurate model on a whole, a non-useful model on a whole. These are the two issues with the data imbalance. right? Class imbalance, if in case that imbalance is with target variable, or biasness in the categories, if in case that's there into generic features. So whenever we deal with any structured data use case, we have to first check, do we have class imbalance 1? Do we have attribute imbalance 2? If in case yes, then we need to treat it, deal with that. We need to take some actions against it before we feed that data to the machine learning algorithm. Let me know if that makes sense and that answers your question, sir. Right. So now I'm going to go ahead and say here, take a new Python notebook, right? And this is going to be, yeah. Meanwhile, let me know any questions so far we have. So this is going to be more like, so we're going to deal with a use case here. Let's understand that use case here, everyone. What exactly is the use case that we're going to deal with? So this is very simple data that we're going to pick today, right? It's very simple data that we're going to pick today. Second. So yeah, this data is about, as you can see here, around it's a data of around 1340 customers, 1338 customers, right? And the idea here is that let's talk about the problem statement first before we get into before we get into a lot of understanding of what problem we're going to go ahead and solve. Right, so let's talk about that section first. So the problem here is that we have an insurance company ABC, right? The insurance company has diverse set of insurance products. The business top level ELT team analyzes the performance of business via dashboard. So they get to analyze the performance of the business over Tableau or Power BI dashboard. While doing that analysis, they identified that one of the KPI, that is sales of health insurance, was observed to be performing negatively or performing low. So while doing that sort of analysis over dashboard or interpretations or monitoring over dashboard, they observed that in last 6 months, the sales of health insurance has decreased quite a lot, and they worried about it, right? So they observed that the sales of health insurance are going down from last few months. They asked the analytics team to sort of perform a detailed EDA to understand why is that sales are going down. So the company observed the decrease in sales of health insurance. Usually company has made at the moment huge investment in marketing and getting the leads for health insurance inquiries. If the sales cannot be handled, if the sales team cannot handle all the inquiries, that leads to loss of business, loss of credibility, and the customers may also shift. If we are not making good sales, the customers who are likely to buy health insurance, they may shift as well from one to another market share. So why is that going down? So it is observed that the reason behind sales is more decrease in sales is more time taken by sales executive in handling one inquiry. The idea is that whenever a customer makes an inquiry for health insurance, they ask a lot of questions. Those questions are more around how much of annual premium charges I have to pay. These are my details. And it takes time for the executive to calculate annual premium charges based on the customer details, right? Based on certain factors as that keep on changing, right? The objective here is to develop a machine learning algorithm or machine learning model which can take the customer details and quickly predict the amount of annual premium charges. If that can be done, this can decrease the time taken by executive to handle one inquiry, and that can increase the number of inquiries they can handle in a day, which would boost the sales on a whole. So this is the key idea towards the use case. The idea is that the insurance company is facing challenge that salespeople are not able to handle multiple inquiries in a day. They just handle few inquiries because one inquiry takes a lot of time by the customer. That leads to a bad customer experience. At the same time, a lot of cost associated with handling inquiries as well. So if machine learning model can be developed, which can predict these accurately, which can make prediction about the amount of annual premium charges, that can ease out the job of handling one inquiry. decrease the timeline also for handling or answering one inquiry. As a part of data, what we are given is we have data of understanding of customers, right? So where we have multiple attributes available over here. Let's see that out here. This is the data of 1,338 customers. For each customer, we have age, gender, BMI, children they have, count of children they have, whether they are smoker, yes or no, which region they come from, and finally we have the annual premium charges they paid. This is the data of customers in the past year. We need to use this data and build a machine learning model and create a dashboard that could be used, or web application that can be used by the sales team in the backend, so that they can make predictions whenever there's a customer inquiry. So we're going to use this data, develop a machine learning model, deploy it to a web page, and that web page should be used by the sales team at the end of the day. That's our end goal. I hope now we have fair understanding to what problem are we trying to solve here, everyone. Right, so we're going to import, we're going to import all the libraries that is needed. Import pandas as PD, import numpy as MP, import matplotlib dot pyplot as PLT, import cbon as SNS. We're going to start with the idea to data exploration, where we simply try to data collection and data exploration, I would say. And this is going to be our step 2, right? From the framework, if we talk about. So we're going to load data here by saying we're going to load data here. Right, so here we have been able to sort of load data, right? So we said pd.read CSV, you have been able to load CSVs. We have 1,338 rows and 7 columns as part of our data set. All of them, annual premium charges, that is charges column, is our target attribute. We'll perform generic exploration here just to understand the data a little better. If you look at df.info, that helps us understanding that, well, most of the attributes are int, the gender is object, the smoker is object, region is object. For object column, we look at the unique values. For example, df.gender dot unique, df.region dot unique, and df.smoker dot unique. Looking at the unique columns, it looks like that in gender we have 2 categories, male female. In region we have categories 4, southeast southwest, northeast northwest. In smoker we have yes and no as 2 categories. So we don't have any hidden missing values stored here like hash or question mark or something. The other attributes are int or float, so they don't have any string associated which may represent a missing value. Looking at non-null data, it also looks like that there's no data missing in this case, so that also makes it super easy to go ahead with. We'll also look at df.describe just to have a quick overview idea of statistical summary of this data. Looking at that, looking at the average mean versus 50 percentile of age, both are similar. That means uniform distribution. BMI similar, uniform distribution. Sorry, normal distribution, normal distribution. Children, normal distribution, and charges heavily skewed distribution, as mean is very high compared to median. Right. Besides that, it looks proper. Let's move forward to the idea of data cleaning. First, we'll check for missing values if we have any missing values. So it turns out we don't have any missing values. We'll check for duplicates. We have one row which is completely duplicating any other existing row. So we can drop that. Finally, we're going to go ahead and check for outliers. df.skew could be one approach to look at the skewness. It turns out the charges column has heavy skewness, which is more than 1. So it is having outliers. Now charges is a target attribute. So if it has outliers, we can one way drop the attributes, but as we know that we have only less of data available here, only 1300 rows available. So instead of dropping, we can possibly do a capping. So what we can do as part of capping is just replace the heavy charges by, maybe you can say just replace the outliers by nearest inliers, right? So we can simply say that d of dot charges, where d of dot charges are greater than d of dot charges dot quantile of 0.97. Let's say all the values which are, all the values which are greater than 97 percentile, will replace them by, let's say, the value at 95 percentile, right? And then look at d of dot skew, or maybe d of dot charges dot skew. We can see that it has become 1.32 from 1.51, which is still not sufficient, right? So I'm going to make it like, 95 and replace it by 94. I'll have to run the whole code again. Gonna restart and run all. Let's see how it goes this time, right? So from 1.5, it goes to 1.27, which is still not sufficient, right? So I'm going to make it like 0.92 and getting replaced by, with value at 90 percentile. Kernel restarted and all. Right. So this time it goes around, 1.11. So they can say that, let's say, this is a little logical one. Give me a moment, everyone. All right. So yeah. So let's say that, to some extent we have been able to sort of handle this out, and now we'll move forward. So next step we're going to go ahead and do is more like, feature engineering. We don't have a lot of scope of feature selection here. Sorry, feature extraction here. So we're going to be doing selection primarily. So let's say numeric versus categorical. We won't be performing any sort of univariate analysis at the moment, right? But here we can look at the correlation analysis. So let's say a few of the steps that we're going to do here is correlation analysis. Right. And we can say core equals d of dot core and PLD dot figure. Eight by 6. Right, so this is the correlation analysis. It turns out that age has positive correlation with the charges 0.31, which is not very positive, but then that's positive correlation. That means higher age people are likely to pay high premium charges. BMI has slight high positive correlation. That means heavyweight people are likely to pay higher annual premium charges, and children doesn't seem to have any sort of correlation with it. So BMI and age are slightly important variable. I should say age and BMI. Age is more important, right? Furthermore, we can perform, let's say, look at certain graphs, and we can possibly also perform certain analysis, such as, let's say, ANOVA, right? So we can perform ANOVA. So let's say xnum equals df of maybe age, BMI, children, and y equals df of charges from sklearn dot feature selection import f underscore regress. We can say here fval comma pval equals f underscore regress x num comma y, and we can say that for I in range of length of x num dot columns, print x num dot columns of I comma p val of I. So assuming 95% as the confidence interval here, let's see reaffirm has no columns, my bad, columns. Assuming 95% as the confidence interval, we can see that for the alpha value would be, so assuming CI is 95, we can say alpha equals 1 minus CI, which is 0.05. So if the p value will be, you can say primarily if p value is greater than alpha, we sort of accept null hypothesis, and you can say feature is not important. And if the p value is less than alpha, we can say reject null hypothesis. Null hypothesis is what here? And feature is important. We can say feature is important. What is null hypothesis? We can say that the variable has similar means in 2 or more groups of charges. Right. That's an idea. So looking at age, the p value is less than alpha, the reject null hypothesis rejected, and the feature is important. BMI, the p value is less than alpha, feature is null hypothesis rejected, feature is important. And children, it is also less than alpha, right? We can say slightly important variabilities as well. Now, quite a similar way we can perform, detailed analysis. At the moment for categorical data, we'll perform some sort of visualization in that case. So let's say we can say here SNS dot dist plot. We can say d of dot charges, where d of dot, let's say gender equal male and equal female. PLD dot legend d of dot gender dot unique. We can say this is like 5 and this is like gonna be 12. So here is where we have gender wise graph. So we have the property density distribution of the annual premium charges for both the gender groups, male and female. We can see that at male customers, at lower charges, you can say slightly male customers are paying, there are more male customers at low charges, and there are more female customers at high charges. That's a slight of difference, right? Not heavily. So you can say there's no much of or not very significant difference in terms of annual premium charges paid by male or female. But yes, slightly you can see at lower charges between maybe up to 20,000, red is above blue, which is male is above female. Whereas at higher charges, female is above. That means there are more female paying higher charges, more male paying lower charges. Right. So that's one idea here. Quite a similar way we can analyze it for, let's say, specifically instead of gender, we can say it is for smoker. So we can say smoker yes versus smoker no. My bad. Smoker yes versus no. So we have blue distribution is for those who are smokers and red distribution is for those who are not smokers. So you can see that they are non-smokers are mostly paying low annual premium charges. X-axis is representing here the annual premium charges, whereas yes, smokers are mostly paying very high annual premium charges, right? So smoker that that makes smoker turn out as a super important variable. right? And that's one idea. Similarly, if we look at, instead of smoker, let's say region, southwest, right? Northwest, northeast, southeast. So we can see that for all the four regions, southwest, northwest, southeast, northeast, the distributions are almost overlapping. That means annual payment charges paid by each of the regions is almost similar. The density of customers paying low to high annual payment charges in each of the region is almost similar. So we can say gender and region may not be relevant variable. Children may be third irrelevant variable, you can see, right? That we want to drop. And we may want to definitely consider age, BMI, and smoker. So let's assume that now we're going to consider important variables or important attributes as age, BMI, smoker, and children, right? We'll also consider gender as well. No, gender should not be, right? So we'll consider this one. So we can say finally our X is going to be DF of age, gender, smoker, children, and a Y is going to be DF of charges. Now we'll shift to the step number 5, which is where we talk about pre-processing of features. So now if you look at x.head here, this is our features, right? And a few of the features are in categorical format or text format, which are gender and smoker, right? So we can transform them right over here. We can use, let's say, simple label encoder to do that. So from sklearn.preprocessing, import label encoder. We can say LE or gen encoder equals label encoder, and X of gender equals to gen encoder dot fit underscore transform X of gender. Similarly, we're going to say small encoder equals label encoder, and DF or X of smoker equals to small encoder dot fit transform X of smoker. Now look at x.head here. So this is how we have those variables encoded. So happy with this. Now we're going to go ahead and split this data into train and test. So from sklearn.model selection, import train test split xtr, xts, ytr, yts equals train test split, and x, y, test size equals 0.2, random state equals 5. Print x.shape, xtr.shape, xts.shape. Print y.shape, ytr.shape, yts.shape. Right. That's an idea here. Done with this, now we're going to shift forward to next step, which is going to be 6, applying machine learning. Right. And this is where, let's say, at the moment, we're going to implement descent tree algorithm, right? Maybe, descent tree algorithm. So we can say from sklearn.tree, import descent tree regression. So it's a regression problem, right? So we want to consider, let's say, a simple linear model. So we're going to say linear model, import linear regression. Right. And we can say here model equals linear regression. model.fit xtr, ytr. And now we can assess or judge the performance. So from sklearn.metrics, import R2 score. And we can calculate here R2 score of y test, model.predict XTS, right? So that turns out to be 73%. So let's assume at the moment 73% is a good ASCII score, which is actually not, right? So you'll finally now export the trained model for production, right? Because that's our main goal, to look at, how do you deploy this in cloud, right? So we'll do the exporting, right? So we can say exporting the model for production. So we're going to say import joblet.dump model as model.pickle. We're going to create a folder here. So I'm going to, in the same directory, I'm going to create a folder called deployment. So I'm going to, just export this inside the deployment folder. Similar way, I'm going to also export the gender encoder and smoker encoder as well, as we'll need those encoders. Right, so those files are also exported. So done we are. Now let's come back to this folder here. So here in this folder deployment, now we have the 3 pickle files available, which we're going to consume in production. And we also need to upload these files as well to AWS cloud, right? Now we're going to create here a sample web application just to deploy this, right? And yeah, that's it, right? So we're going to go ahead and create. So I hope we get till here so far. Any questions, let me know if till here before we take ahead, go ahead and try out deploying this to production. I hope we're good so far, even. Any questions in out so far till here before we go ahead and try out deploying this to production? Right, good so far. Let's take a step ahead, right, and move forward, right? So we'll now create a file here, new file, which is text file. Let's say it's going to be, I'm going to name it as more like app.py. From Flask, import Flask, right? Right, and we're going to go ahead and create an app as in Flask __, right? And we're going to say app.root / and we're going to say here, this is going to be methods. Getter post. I'm going to say def main function, right? And at the moment, we're going to simply return hello world from Flask. We're going to say if __ main and __ name __ equal __ main __ in that case we'll say simply In that case, we'll say simply app.run. Right, that's it. This is it, right? So there's a sample app we have created here with Flask, right? We'll go to the location and try out, we'll go to that location and try out wherever this code is saved. We'll go to that location and try out executing this app. And let's see if it works well, all right? Deployment folder, and we're gonna say CMD here. Python space app.py. And this is where our app is running. Let's go ahead and try out sending it a request. So if I try out sending it a request here, you can see on 127.0.15000, it says hello world from Flask. So I've been able to create a sample web application right here, to which we send a request, it's able to respond. Now, with this web application, we'll try to integrate one HTML file and try out sending that HTML file instead, and try out collecting a request from that HTML file or data from that HTML file. So we'll say import this and import render template. Right, and we'll instead respond with render template. Right, that's one idea. And yeah, that's one idea. So now let's go ahead and create that HTML file here. We're going to say here, this is going to be, let's say, index.html. We're going to say this is right. I'm just going to, bring this code over here from one of the repo. Quickly, so that it goes a little quick in HTML. We don't want to write. We don't want to keep writing manual codes, right? So I'm going to go ahead and bring it from there. Just a moment. Right, so I'm going to take it from one of my repo here. Let's say templates index.html, and we'll go ahead and modify this repo. Modify this code. Again, this index.html should be actually in the templates folder. So that's what one of the things that we did it wrong. Let me close this and move this to a templates folder. So we're going to create a folder here called a folder, and the name of this folder is templates. Right, and move this file index.html into templates. Here we have now index.html, right, which is actually more like a code like that. So we're gonna just edit it right here. So we're gonna say edit. So we come to the machine learning dashboard, and we are sending it to predict page, right? And we're gonna say here, ask for the few details. So we can ask details such as age, whether customer is smoker, right? So we're gonna say age, and we need that detail in years, right? Gender, we need that detail as male or female as text, right? We need whether the customer is smoker, like yes versus no, right? So we're gonna show those details. And finally, children, 0 to 6. We're gonna give these a certain key here. So age, gen, small, CHL. That's it, right? Designed by, I'm gonna say not Kaizen, let's say designed by Trek Trunk, right? That's it, right? So this is a standard HTML form that you created here, and we want the code to simply throw this form when it is a request is made. Let's go ahead and run this and see this out if it works well. I'm going to stop the server and run the server again. Go to the browser, send a request this time. So we can see that we are able to get the age in years and all those sort of details here. What else can we do is we can add one more line break here if needed. Now, typically we would want to get these details inside the app.py. To get those details, we're gonna say here, we're gonna create another page, right? Which is gonna be /predict. And this is, let's say, predict method. This will render, let's say, another file, which is output.html, right? And over here, what you can do is we're gonna simply say here, accept the data. So data equals to request dot form, data equals to dict of data, right? We're gonna simply print data just to understand, are we able to receive data or not? And you want to simply send this data as in comma outputs equals data. We'll also create one more HTML page here, which is, we'll say file new output.html. I'm just going to copy a certain template over here as well. Right, so where we are saying that, insurance annual premium prediction model, and we're going to say output.items. It should do this and go back like that. And here we're going to say output equals data. That's it, right? So let's see if it works well this time, right? So we are simply trying to accept the data from the user and see that are we able to get the data or not, right? So let's say I'm going to again send a request on 127.0.0.1, age in years. Let's say I enter age as 25, gender as male, smoker is yes, children as 2. Click on submit. So that data should be received here. So we can see that we are able to get that data, age, gender, male, smoker, children. And this shows the data at the moment to us. Right, and that's it. So now we would want to make predictions, within the app.py. To make predictions, we'll again import joblib, right? We'll also say here load the model as joblib.load model.pickle. We're gonna say gen encoder joblib.load gen encoder.pickle smo encoder equals joblib.load smo encoder.pickle. Then we have loaded all of them. So once we have this data, we're going to say here is data of data2 equals data.copy, right? So we're going to simply copy that. And I'm going to say here data2 of let's say gender equals gen encoder dot transform this. And similarly, we're going to say here for smoker. So we're going to simply convert the smoker into whatever smoker data that we get or gender data that we get from string to text number, so that we can feed it to the machine learning algorithm. Done with that, we are right. We're going to simply align those values in a similar arrangement. So we're going to say here data2 equals a list of data2 of in the same sequence where we had our training data in the case study, right? So what was the sequence of training data? You can see age, gender, smoker, children. The same sequence we need to align here. So data2 of age, comma data2 of gender, comma data2 of smoker, comma data2 of children. Once we have this, we can simply go ahead and feed this to the ML model. So we can say pred equals model.predict data2. And finally, we can say data of prediction equal rid of 0, right? So that's how we can access the value. And that's it, right? Let's see if it works well. Try out sending a request here, go back, click on submit, got an error. Why should be a 1D array, got an array of shape 0 instead. All right. Let's make prediction here. So first, we got an error here, and that error has occurred in the line 20, which is where we are trying to do encoding, right? So in encoding, it expects it to be 1D array. So we need to pass this inside a bracket actually here. Bracket for this as well, a bracket for this as well. And now it should do the job. Control C, run this, and let's see it out. Submit. Got the prediction done this time. Looks like, we have got a warning. So yes, we got a prediction done this time, right? So this works well, right? So we are able to sort of make a prediction with this, right? We are able to, get the prediction done on this, right? So this is where we have got a completely functional web page in which we can enter here the details. As soon as I enter, let's say 25, or maybe I enter 58, male, and smoker, no, right? And children like 3. So submit, generates, certain prediction out of it. So by now we are sort of able to develop predictive model, deploy it as a web application. Now we're going to go ahead and shift this to cloud. Well, before we go about shifting this to cloud, any questions still here, everyone? Are we good? Does this make sense to us? Let me know. Right, good so far. So now we're going to go ahead and deploy this to AWS. For that, we'll have to create the environment, right? We'll have to, one, create the environment, and two, we'll need to sort of also align our code in that manner so that, it gets deployed there, right? So we need to do a bit of modification in the code specifically for AWS, specific requirement, right? And that's it, right? That is it. We should be sort of able to deploy it to AWS quite easily, right? So the same format, right? A bit of difference here we'll have to make in the main web app, you can say, right? So we're gonna say simply, one of the difference that we need to do here is we're gonna just put here debug equals false and host equals 0.0.0.0, right? And port is 5000, right? So that's the only key difference we need to do. Rest all it's proper, right? So let's go ahead and push this out to AWS, right? For that, we'll now go to the cloud here, everyone. In AWS cloud, we're going to create an EC2 instance. So this is the AWS cloud, right? And AWS management console. I'm going to go to services option, click on EC2. So you have AWS account for this. Once here, we'll launch an EC2 instance. Click on launch instance. Right, so we get these sort of options as which instance we want to select here, as in what is the type of instance that we want to go ahead with, right? And based on the configuration and the type of specific instance, we need to sort of select the specific operating system. So we're going to search for Ubuntu here, right? And maybe we can first select the you can simply search for Ubuntu over here. So you can see that there are two options: Ubuntu Server 20.04 and Ubuntu Server 18.404 LTS, right? These are the both the options, and both are eligible in the free tier. At the moment, I'm using free tier, so I'm going to select any one of these two, right? And I'm going to for Ubuntu this version, which is 18.04 LTS. Right now, it's going to ask for the specific option, so we're going to select it to micro. right? That's eligible one, right? I mean, that's one we're going to go ahead with. And simply we'll click on the option of review and launch, right? And moving forward, security key. So we're gonna say here, let it be, click on launch option. Last quote, choose an existing key pair. We're gonna say create a new security key, give it a name such as AWS key. Download the key pair. So when you create instance, it's gonna ask you the security group, and you need to sort of download that key pair. We'll use that to connect to this and launch instances. So this should, simply launch an EC2 instance, which is more like a virtual machine on AWS cloud. And now we should be able to deploy our ML model, the Flask code on this specific virtual machine. Right. So let's go ahead and see this one, right? So we have instances. You can see that this is the instance that we have deployed, right? And at the moment, it may not have got successfully deployed. It'll take a little while to get it deployed. Well, that's not a challenge, right? Now, we need to have few tools to be able to connect to this and do some sort of modification as required. So first thing that we need to have is Putty. So Putty will connect to this and try to access the instance, install some set of software, and we'll need to also have WinSCP, via which will simply do some sort of file transfer. We'll upgrade this. Before we do that, we need to have I'm just going to download the latest version of WinSCP, right, as it is the older version available to me. And gonna go ahead and complete the download here. Installation. Finally, I'm going to open the Putty Gen, right? So Putty Gen is going to help us out to generate the private key from the current key that is downloaded. So here is Putty Gen. So here we'll go ahead and simply first load the private key that we downloaded, right, which is in the downloads folder at the moment. And I think I downloaded it, right? Or else I'm going to go ahead and say file, load private key. Right, we'll try to load it, and then primarily what we need to do is we need to sort of generate a key which we can use, to download, right? So first, let me just ensure that it's downloaded, right? That's one important thing. So it's AWS key.pem that is downloaded. So I need to go to Putty Gen here. Putty Gen and load. Go to the downloads folder. I need to, as it is not showing the options, right? So I need to do here sort of all files. All files. So it will show the option of PEM file that we just downloaded. So it has imported that. Once it is imported, we'll say save private key. And I'll save it somewhere. Let us say I'm going to save it here in D drive, AI, track trunk, and going to save it to deployment folder. My AWS key.ppk. So this is how we have converted the public key which we downloaded into private key, and now we should be able to use different tools to do file transfer. For example, we'll be able to use, let's say, WinSCP, and WinSCP will try to connect via this key and do file transfer. So let's do that here, right? So here we go, and this is the public IPv4 address. I'll go back to instances. You can see this instance is now running. And here we have public IPv4 DNS, which we can copy, go to this host name and paste it here. For security, we'll go to advanced option. We'll go to SSH, authentication, and load the key here. And for that, we'll say drive, AI, tech trunk, deployment, and key. That's it. Say OK. And click on open. Right? So I'll click on login. So this should help us to connect our local machine and or to the virtual machine which we have created. Right. So I'm going to say username Ubuntu. So it's going to simply help us to get it connected. So we are connected now. Now, once we are connected, we should be able to sort of do all set of file transfer over here. Right. So I'm going to do the file transfer. But before that, we need to go to that location where our codes are saved. Right. So I'm going to go to the tech trunk folder. Deployment folder and say OK. So transfer these files, right? So I'm going to transfer this, transfer app.py, generic pickle, model pickle, and this one, right? So these are the files I'm going to transfer here. So these are files now getting uploaded on the virtual machine which we have created on the AWS cloud, right? So app.py templates, generic pickle, model pickle, and some smoke encoder pickle, gender encoder pickle and smoke encoder pickle. All of these files are uploaded there. Once uploaded, we are done. We are happy with it. We're going to say yes, and done we are. Finally, the next step is going to be we're going to connect to that via Putty and going to go ahead and simply, install some set of software and launch it, right? But before we do that, we need to simply, we can simply do the all installation of software. But before we do that, we need to do a bit of security configuration. So for that, we'll go ahead and security configuration. Just need to allow all the traffic because, by default, 80 traffic or 80 port numbers are allowed. We just need to allow port number 5000, as a part of security, right? So that, that port number is not blocked and we should be able to access it. To do that, we'll go to the security using network and security groups. We'll click on the option of create a new security group. We can name it as my custom group. Allow all traffic. Right. Rules, we'll add an inbound rule where we'll say, simply add inbound rule, say all traffic should be allowed. Right. And source will say from anywhere, IPv4 address. Right. That's it. So that's an inbound rule we have created. Similarly, outbound, all traffic is already there, right? And we need to click on create security group. Once we have created the security group, we need to simply go ahead and associate the security group with our, instance. For that, we'll go to the option of network interfaces. For that, we'll go to the network interfaces, right? And we'll simply select this option and click on the action, change the security group. And we'll select the security group, which is, let's say, my custom security group. Add this, click on save option. That's it, right? So now we'll go ahead and try out connecting this via Putty and simply do all sort of software installation. So we'll go to the Putty option and click on the instances, copy the public IP address, go here, go to the SSH, authentication, browse the key, right, and click on open. So this should simply open the terminal of that virtual machine, and here we should be able to do all sorts of installation. And we should be able to do all sorts of installations. So now we can see that we have access to the terminal of the system, right? And we can check here ls, all the files are already there, app.py, gender encoder, model.pickle, some smoke encoder, all those files are already there, right? So now first we'll do here sudo apt get update. So this will simply update the Linux operating system, which is the Ubuntu operating system. And then we'll have to install Python over here, right? For that, we'll write here sudo apt get install python 3 -pip. So this should simply install Python 3 over here in the current virtual machine. Once we have, we will install all the libraries that are required. So we're going to go ahead and now install the libraries that are required. For that, we'll simply say here pip3 install the name of libraries, right? Let it get done quickly. So we're going to say pip3 install pandas, numpy, scikit-learn, joblib, and flask, right? So these are the libraries primarily that we need. We can also put matplotlib, right? And scipy as well, although not very necessary. We could also create a requirements.txt and put it installed there. Right, so these libraries should be installed. When this library is installed, you can say our infrastructure is ready, our setup is ready, where we can run that app.py file, which we uploaded to the virtual machine. Now let's go ahead and run this. So I'm going to now run the app where saying Python space app.py. So this should Python 3 space app.py, my bad. This should typically start this server. So it says server is running over here. Now let me go ahead and copy this and go to the server here. So now this app is running on AWS cloud. Let's try out accessing it. Yes, I may have to say here colon 5000, right? As I didn't customize the port. So when I say colon 5000, we can see that we are able to access it. I enter my age, which is, let's say 24, gender, which is male, yes, and children 2. Submit, gets the prediction. That's it. So we have deployed this to cloud. Give it a try here and let me know if it works for you. I have shared the link in the chat. This is where we have deployed the model on the cloud, and now all of us should be able to access this model as a sales dashboard, and we should be able to sort of make prediction with it. This go back button won't work out in this case because the link is different on that. But besides that, it should work fine. Give it a try. Let me know if it works well for you. Okay, so does it works well for us? right. That was it. So this was so far a whole idea on understanding how do we develop model and deploy it to cloud, right? So that's where we are done with the the content and the objectives of the webinar for the day, right? So you can drop an email to TechTrunk, I think contact@techtrunk.in for files, or else I think they should be sharing with the same email with which you have accepted this request for the webinar. That was it, everyone. So we'll take a pause here. Thank you all for joining the webinar today. I hope you would have enjoyed it, and mostly we'll get to see in other webinars moving forward. Thank you very much. So we'll call it a close and take a pause here. Thank you.